Hi everyone, and welcome back to diuretics topic in our MC2, right? So I think we have learned the different classifications of diuretics and followed by their structures, their mode of action, okay, like carbonic anhydrase inhibitors and followed by the thiazide diuretics. Likewise, we are coming one by one class of diuretics explanation, okay. So in this class, so here we are going to learn about the loop diuretics. It's about the loop diuretics, okay. So it's another class of diuretics which are extensively used for the as a diuretics, right? So these are the special class of diuretics, okay. So these diuretics produces the peak diuresis or urine, okay. That means, so these diuretics have a special character or ability in terms of producing the more diuresis or urine much greater than that observed with the other commonly used diuretics, okay. That means, so whatever the other commonly used diuretics and compare with the other commonly used diuretics, these loop diuretics, they will produce the peak uresis, that means high urine production usually, right? Hence these loop diuretics also called as high ceiling diuretics, okay. So these loop diuretics also call it as a high ceiling diuretics, okay. Some of the important medicinal chemistry textbooks also explain about this high ceiling diuretics, right? Yeah. So yeah, so these are characterized by the quick onset, okay, very quick, they used to show very quick onset around 30 minutes for quick mechanism of action, and very short period of duration, okay, entire duration action that can able to produce within a 6 hours, okay. So that is the importance of loop diuretics. So most of the people, they used to use they used to prescribe these loop diuretics for the when it comes to the different heart disease, different heart related problems, and like hypertension and congestive heart failures conditions, in the case of edema also, right? So now what are the important examples given in the loop diuretics, okay. So there are 3 important examples has been given in the loop diuretics to extensively study in the case of MC2, in this MC2 syllabus, right? So first one is about the furosemide, right? It is about the furosemide, okay. So when you look at the structure, we have seen the structure and discussed a little bit about this furosemide. It's aromatic sulfonamide derivative and having this furan ring, okay. This furan ring in the this furan ring, okay, here in this furan ring here. That's why based on this furan ring content containing this derivative, that's what's called the furosemide, okay. Next is about the another class about the bumetanide, okay, right? It's about the bumetanide. It is also aromatic sulfonamide derivative we have seen here with the N-butyl, okay. There is a N-butyl side chain. So based on the butyl side chain, it is called as a bumetanide, okay. Another is about the ethacryonic acid, okay. Another class about the ethacryonic acid. It's aromatic derivative. So basically aromatic with the dichloro substitution, okay. So it's called the acryonic acid derivative. Based on this acryonic acid moiety derivative, based on that, it is given as a ethacryonic acid derivative, okay. These are the 3 examples has been given in this loop diuretics, right? Now just we have learned about the loop diuretics and importance, followed by the structures given in the MC2 syllabus point of view. Now we are going to be learn about the mechanism of action of loop diuretics. What is the exact mechanism of action of loop diuretics, right? So if you have seen this, right, it's the Bowman tubule, okay. If you have, we need to identify the first site of action in the Bowman tubule and followed by the exact specific mode of action of this loop diuretics in the case of this Bowman tubule, we need to identify, right? So we have seen this one, right? This is called the Bowman tubule, okay, we used to call, and we have a different spots like loop of, okay. So like descending loop of Henle, ascending loop of Henle, right? Again, this is called as this entire part is called as a loop of Henle, and this loop of Henle, it is called as a like descending loop of Henle. It's called as a DCT, okay. Descending loop of Henle, and followed by this one is called as a ascending loop of Henle, okay. It's called as a descending. It's called as ascending loop of Henle, okay. This entire part is called loop of Henle, and this is the descending, this is the ascending loop of Henle, okay. Okay. Now, so these loop diuretics, especially, they are going to show, they are going to say their mechanism of action at the particular site of this loop of Henle, that is on the ascending loop of Henle. Okay, this is the ascending loop of Henle. This is where this loop diuretics or high ceiling diuretics, they are showing their site of action at the ascending loop of Henle. Okay. Now, so what is happening? Okay, exactly at the site of ascending loop of Henle, how their mechanism of action is going to be shown by this loop diuretics, right? So when it comes to the ascending loop of Henle, okay, we have seen this about the sodium and potassium by 2Cl minus co-transporters or symporters we have learned in the case of thiazide. Okay. Similarly, here is also kind of symporters will be there. Okay. So those symporters are same symporters which are almost similar, that is the sodium by potassium by 2Cl minus symporters. Okay. This is where the are co-transporters. Okay. Now this loop diuretics like furosemide and bumetanide and followed by the ethacryonic acid, okay, all they will show the their mechanism of action by the inhibition of these sodium plus by potassium plus by 2Cl minus symporters present at the ascending loop of Henle, okay. So and this is where the we know that, right, the transportation of ion takes place in between the lumen, right, and followed by the inside and outside this loop of Henle, okay, especially like sodium and potassium ion transportation with exchange of these 2Cl minus ions, okay, right. So they used to collect like that, okay. Now this is how they are showing their mode of action, especially, right. So loop diuretics, especially mainly the loss of sodium and water and followed by the hypocalemic metabolic alkalosis and followed by the increase the calcium plus 2 loss, okay, right. So and specifically we can able to be like commented on this, right, as the diuretic effect of ice sealing diuretics is attributed to, right. So yeah. Okay. The diuretic effect of this ice sealing diuretics, okay, especially like loop diuretics, attributed to the inhibition of luminal sodium by potassium by 2Cl minus symporters located in the thick ascending limb of loop of Henle. Okay. Thick ascending limb of this thick ascending loop of Henle, right, leading to the sodium plus rich diuresis. Okay, that's how they are going to share their they are going to show their mechanism of action, and they have the very high diuresis activity that can able to produce the peak diuresis when compared with all other diuretics, right? Yeah. Next is about the one by one class of this loop diuretics we are going to learn. Okay, among all these loop diuretics, one of the important loop diuretics is about the furosemide, right? So furosemide, and there is a star mark, okay, so that is indicating that, okay, we have to learn the synthesis of this furosemide, right. Now when it comes to the chemical class of this furosemide, which comes under the aromatic sulfonamide derivative and followed by the this amine which contain this furan moiety, okay. That furan moiety is, okay. That furan moiety, based on that furan moiety containing, it is called as a furosemide, okay. It is one of the important bit aspect also, like they used to ask about the heterocyclic ring which contains into the furosemide is also a furan ring. Based on the furan ring, the names comes as a furosemide, right. So so it has a very soluritic effect, okay. That means it is a soluritic effect. That means urine production with the salt content, like especially high content of sodium, okay, will be like. So it is around 8 to 10 times more effective than thiazide diuretics. Okay, we have learned about thiazide and hydrothiazide derivatives. It is more effective than it is more shows the more activity more than 8 to 10 times of the thiazide diuretics what we have learned in the previous class. Okay. Now, so then we have to learn about the synthesis of furosemide, right? Synthesis of furosemide, since there is a star mark has been given. Okay. Now we can synthesize this furosemide by taking the starting materials, right? 2,4 dichlorobenzoic acid, right? So it's a benzoic acid 1, 2, 3, and 4, right? There is a 2,4 okay, dichlorobenzoic acid. Okay. So when you are taking this 2,4 dichlorobenzoic acid on reaction with chlorosulfonic acid, this is called as a chlorosulfuric acid. Okay, it is a almost similar derivative of this sulfuric acid is found on king of chemicals. If you substitute one hydrogen with the chlorine, we will get the chlorosulfuric acid. Okay, if you react this on 2,4 dichlorobenzoic acid with the chlorosulfuric acid, and you will get the sulfonamide derivative at the at the end at the end meta position of this dichlorobenzoic acid derivative, right? So there is a carboxylic acid group, alternative triene group. When you do the sulfonation, okay, it will undergo the sulfonation, forms the sulfonyl chloride at the meta position of this with respect to the chlorine. It will give this chlorosulfonic acid derivative of 2,4 dichlorobenzoic acid, right? So and upon this sulfonyl chloride derivative on reaction with, on treatment with ammonia, okay, so ammonia is a base, well known, very familiar. Now ammonia will undergo the substitution of this chlorine atom, and by substituting the chlorine atom, and it will get the ammonia derivative. Okay, the ammonia derivative is sulfonamide. Okay, you will get the sulfonamide moiety. So it is obtained by the simple sulfonyl chloride preparation and followed by the treatment of the sulfonyl chloride with the ammonia will leads to the sulfonamide derivative. Okay, so so after synthesizing the sulfonamide derivative from the sulfonamyl chloride, okay, we will get the sulfonamide. Okay, so this sulfonamide, okay, which is on reaction with this furfurylamine, okay, it's all called as a furfurylamine. It's a furan derivative, furan having this NH2 group, right? So and which is on reaction with this furfurylamine, what will happen? So whatever the chlorine, okay, one of the chlorine atom of, okay, adjacent to this carboxylic acid will undergo this aromatic nucleophilic substitution with this furfurylamine. Okay, that leads to this N-alkyl substituted furan derivative, N-alkyl substituted furan derivative, and leads to give the final molecule of furosemide. So that's how we can simply, we can synthesize this furosemide simply by taking the 2,4 dichlorobenzoate starting material, followed by the chlorosulfonation, followed by the treatment with the ammonia. We'll get the sulfonamide derivative, which is on which is on reaction with the furfurylamine, that leads to the formation of furosemide as a final product. Okay, that's how we can able to synthesize this furosemide as a final molecule. Okay, yeah. Next we are going to learn about the next one by one class of this loop diuretics, right? Okay, so just like furosemide, what we have learned. Okay, right? So in this loop diuretics class, okay, in this loop diuretics class, they are given about the bumetanide. That is about the bumetanide. Okay, so in this bumetanide, it is also this aromatic sulfonamide derivative. Okay, since having this butyl side chain, it is named as a bumetanide. Okay, especially this bumetanide is almost shows the similar kind of action like furosemide mechanism of action, and it used to treat the mainly swelling and followed by the high blood pressure, high BP. Okay, and this includes the swelling as a result of the heart failure. Okay, because we used to swell different organs because of the heart failure condition or liver failure conditions. Okay, on that conditions they extensively use this bumetanide as a diuretics. Okay, to control that swelling as well as edema. Okay, next is about the ethacryonic acid. Okay, one more derivative. Okay, this comes under the ethacryonic acid derivative, ethacryonic acid derivative, where we can have this ethacryonic acid, and which is substituted with this aromatic ring with the dichloro substitution, and which is having the this acetic acid substitution. Okay, phenyl acetic acid substitution here, right? So in this ethacryonic acid also is a diuretic that used to treat the edema, right? Especially which will be useful to treat the edema. Okay, this pill is used to treat the edema associated congestive heart failure, CHF. Okay, and followed by the cirrhosis and renal diseases. Okay, especially used for the cirrhosis and followed by the renal diseases. Okay, likewise both these loop diuretics are extensively used because of their eye sealing nature of or peak urosis production of these loop diuretics. Okay, next. Yeah. So just and followed by we are going to learn about the potassium sparing diuretics, where so there are in the potassium sparing diuretics there are 3 molecules as given as a potassium sparing diuretics. Okay, One is about the spironolactone. Okay, it is a steroidal moiety. Correct. It's called as a spironolactone, steroidal moiety. Another is about the trimerterin. Okay, right. Trimerterin is another molecule, is a bicyclic heterocyclic molecule, and followed by the amiloride. Okay, these are the important class of diuretics has been given as a potassium sparing diuretics. Okay, so when it comes to the potassium sparing diuretics, okay, it's clearly indicating that, right? What is potassium sparing? So potassium sparing diuretics are nothing but, okay, they are also active diuretics, but they will not, okay, they used to spare the potassium ions, okay, while producing the diuresis. Okay, that leads to the hyperkalemia condition. Okay, anyhow, so the class of diuretics, right, the class of diuretics characterized by their ability to increase the only sodium plus and Cl minus excretion without a concomitant increase in the urinary excretion rate of potassium ions in collecting duct. Okay, so these potassium ions, okay, the site of action of these potassium sparing diuretics are at the collecting duct in the Bowman tubule, where they can able to increase the urine production only by the elimination of sodium and potassium, sodium and Cl minus ion. Okay, but they used to spare the, okay, this potassium ion at the collecting duct. Okay, right. So yeah. So these are also known as right, anti-kaliuretics. Okay, anti-kaliuretics agents. Okay, because they used to spare the potassium ions. Okay, especially they can be, these potassium sparing diuretics are further classified into the two classes with respect to the mechanism of action. Okay, what are those? First one is about the androsterone antagonist, and followed by the sodium plus channel blockers. Okay, based on their specific mechanism of action, they are going to be sub-classified into the two categories. One is about the aldosterone antagonist, and followed by the sodium plus channel blockers. Okay, sodium plus channel blockers. So just we have learned about the potassium diuretics, structures and their sub-classification. Okay, based on their mechanism of action.